Now, when the Taylor series for a function is an alternating series, we have a much easier way of controlling the error. Suppose I'm talking about the function g of x equals cosine x, and I want to approximate values of cosine x near the point a equals pi over 2. I'm going to use a Taylor polynomial for approximation, and I'm going to use the third Taylor polynomial of the function at a equals pi over 2 to approximate. So I need to find the first three derivatives of this function, and the 0th derivative is the function itself. It's cosine x. The first derivative is minus sine. The second is minus cosine, and the third is sine. And then I evaluate all of these at pi over 2, and I get a sequence 0, minus 1, 0, 1. And the Taylor polynomial, the third Taylor polynomial at pi over 2 is cosine pi over 2 plus its derivative at pi over 2 times x minus pi over 2 plus its second derivative at pi over 2 factorial times x minus pi over 2 squared plus the third derivative at pi over 2 over 3 factorial times x minus pi over 2 cubed. And because I'm evaluating the derivatives at pi over 2, the odd powers remain and the even powers disappear, which is contrary to what happens when I'm taking the Maclaurin polynomials of cosine of x around x equals 0. So my third degree Taylor polynomial for cosine of x at a equals pi over 2 is minus x minus pi over 2 plus x minus pi over 2 cubed over 3 factorial. And I claim this is a good approximation to cosine of x for values of x near pi over 2. I can actually get some control on the error here using my knowledge of alternating series. So for any point in the interval pi over 4 to 3 pi over 4, notice this is an interval centered at pi over 2, the Taylor series for cosine of x at a equals pi over 2 is an alternating series. And of course this alternating series converges to cosine of x for any given x in that interval. The error is the absolute value of the remainder, which is the absolute value of the sum of the series, minus this third degree Taylor polynomial. It must be less than or equal to the absolute value of the next term in the series. So for any given x, the distance between cosine of x and the third degree Taylor approximation must be less than or equal to the absolute value of x minus pi over 2 to the 5 over 5 factorial. And because x is in the interval from pi over 4 to 3 pi over 4, the absolute value of x minus pi over 2 is less than or equal to pi over 4. So the absolute value of this error must be less than or equal to pi over 4 to the 5 over 5 factorial, and that's approximately 0.0024. So this really is a pretty close approximation to values of cosine of x in the interval from pi over 4 to 3 pi over 4.